Hi guys, this video is on the difference and sum of cubes. This is the type of factoring that's going to be brand new to you this unit, and it's probably the hardest factoring you're going to have to do because it is, not just because it's new, but because it kind of requires the most memorization. And if you think back to the difference of squares that we did in the last video, we can only factor the difference of squares. For cubes, we can factor the difference or the sum of cubes. And if you compare the two forms, really the only thing that is different is in the signs. And we have a tool to help us to remember the signs. It's called SOAP. And that stands for same, opposite, always, positive. So if we take the sign that we're starting with in our, so like this is a difference of cubes, is negative. So the first sign is the same, it's also negative. The second sign is the opposite, so positive, and then the last sign is always positive. Same thing here. So if I have the sum of cubes, my sign is the first sign is going to be the same, also positive. The second sign will be the opposite, so it'll be negative, and then the last sign will be, again, always positive. So we are looking for, again, a binomial, two terms, and we're looking for perfect cubes. So we have an x cubed, so that's a perfect cube. Anything that is, any exponent that will be a multiple of 3 will be a perfect cube. So x cubed, x to the 6th, x to the 9th, those would all be perfect cubes. And 27 is also a perfect cube, that's 3 squared. And I have this list over here. I think these are all of the ones that are kind of fair game that you should be able to recognize, all the way up to 10 cubed. Okay, so the first thing that we're going to do that's going to make up the problem a whole lot easier is rewrite this as the sum of two numbers being cubed. So obviously the first thing that's being cubed is the x, but I want to rewrite 27 as 3 cubed. And so now this x is going to be the x in my example here, or rather this one. The 3 is the y. Okay, so we're going to set up the first set of parentheses. What we're going to do first is just take the first term and the second term and add them together. And when I say term, I'm talking about here what is being cubed. So I'm going to have x plus 3. Again, my sign is going to start as the same as the problem. Okay, next up, I'm going to have x squared. So that first term, that first thing being cubed, I'm going to have x squared. My next sign is going to be the opposite of what I started with, so it's going to be negative, and I'm going to take my x and my y and multiply them together. So x times 3, or 3x, and then my last term is my last sign is always positive, and I'm going to take my y and square it. So that's 3 squared, which is 9. So x cubed plus 27 is x plus 3 times x squared minus 3x plus 9 in the factored form. We'll take a look at one more example together. Here we have a difference of cubes. Once again, I'm going to rewrite both of my terms as cubes. So first off, I have m cubed minus, and if I check out my handy list over here, 4 cubed is 64. So I'm going to write this as 4n cubed. So according to my format up here, I'm going to take my first term and subtract my second term, so x minus y. So I'll have m minus 4n. Again, first sign is always the same as the one that I started with. Next up, I'm going to have x squared. So that's that first term squared, m squared. My second sign is always the opposite of what I started with, so positive. And then I'm going to multiply x times y. So that would be m times 4n, or 4mn. Last sign is always positive, and I'm going to take 4n squared. Now be careful here, I'm squaring the whole 4n, not just the n. So 4 squared is 16, n squared, and that's my factored form.